Welcome to Papa Junk Shop. I just thought I'd bring you up to date on the Onan project. I got it cleaned up as good as it's going to get. Got it mounted on the cart, and what I did was use the original cradle that it was in when it was in the motorhome, and I just cut the brackets that used to be some brackets that come up here, then they had a lip on them on both the front and the back. I just cut them off. You can see here where the original plate ended. Right here's where I cut those off. And I had these set of wheels. They were on a welder that was in the scrap. As a matter of fact, there was two of them when we went out to see the wife's dad in Idaho, and they were in the scrap pile at one of the relatives, and I said, boy, sure would like to have them wheels. And he says, well, I think we can wrestle them off there if you can find a place to pack them in to take them home. Well, I wanted them bad enough, so I brought them home. And they're really nice wheels. They're like cast iron with a rubber band around them. And like I say, they were made for a pretty large welder, so they're capable of the weight. And the front handle is really nice. It's spring loaded. Returns to the up position. And it moves really nice. And all I did was, this was part of the wheels, so I just added a piece of angle iron on here, welded it here and here, and welded it here and here, top and bottom, on both sides. And the back wheels are on a frame, and I just tack welded them here and in the middle, and then the bolts that actually held the original generator in go down through that also. Made a little bracket for a battery. Made an outlet box. And I have a frequency meter and a volt and amp meter on it. And I run it for about an hour the other day. Seemed to work fine. So, got some paint on the muffler. So what I plan on doing next, as long as I'm playing with generators, which I really like to do, I'm going to make a load bank. Oh yeah, I also got this $15 Champion governor fixed and operational. That's also 4,000 watts, so it says. So what I want to do is build a load bank so I can test some of these. And what I've got in mind is I have a... Yeah, let me put this on a tripod. I'll be right back. Okay, now I'll have a little bit steadier camera at least. 2004, I went to an auction, Boise school auction, and they had an electrical motor and generator department that I guess they were closing out or whatever, so they got rid of a lot of stuff. And this was a, I don't know if you'd call it a load bank or a dummy load or what. But it's got a tag on it. I don't know if I can get it so you can see it or not, but it's a wire wound power resistor made in USA, and it's 56 ohms, 11 amps, 10 horsepower at 460 volts. So what I'm thinking is that at 460, if you cut that into 4, you divide it by 4, so you got 115 volts, 120, should be 4 times that, so it should be good to 44 amps, I'm thinking. And these are the resistors. They are, place I can read it, 3.5 ohms a piece. And you can see they're pretty big, healthy resistors. And what I plan on doing, there's 16 of them, so I want to break them down into 2 sections of 8, and I'm going to put them in series, and then I'm going to feed one end like with a neutral, and I'll take the hot and I can switch it like at the end, and it'll have the most resistance, so it'll be the least wattage. And then I can move up one resistor at a time via some, I'm going to use circuit breakers just because I happen to have them. You could use switches or whatever, but I didn't have enough switches alike. So I want to go up through, and when you get to the just one of these at a time, which I tried on the Onan, and with just one of these on 120 volts, it draws 32 amps. So the final one will be 32. So if I got 2 strings like that, if I parallel them, I should be able to get 64 amps at 120 volts. Or it'd be, have it set up so I can do 220 also. So it's kind of still in the thinking stages, but that's where I'm going to try to go with it. So I'll show you as I'm going along what I come up with. Okay, I think I'm gaining on this project. I did some experimenting with a volt and amp meter, a double pole, double throw switch, which I'm going to use to switch from series to parallel for the 2 separate sections of heaters. And I got half of my breakers, which I'm using to switch the coils in and out, mounted. And I took a 5/16 rod, put a couple of square nuts on the end to hold it up off a little bit, and a couple of straps to strap it in place. And then these are square D breakers. They'll clip right on that 5/16. That's sort of like what was in the original box. Wished I had the guts out of an original box, but I don't. And I got some copper bus bar, but you think I can find it? Found a lot of other stuff I didn't want, but I can't find that copper bus bar. So I wound up using a piece of copper tubing. I ran it through my roller to flatten it out, and got all the breakers fastened here on a bus bar, so this will be the common, and then the out will come out the original screws. And it's on a piece of plexiglass or Lexan. These are 1/2 inch 1224 brass screws, and they stay about 3/16 of an inch clear of the bottom, so everything will be insulated. And what I wound up doing with these breakers is I found a really nice big heavy crimp-on lug that I've got, and it just fits in that where they snap in the box originally, just nice. So what I do is I snap that in place there, and then I just run a bead of solder on there just to make sure, and that helps hold them in place too. So that's where I'm at so far. Oh yeah, and I also found some high temperature number 12 wire, which of course come from an auction. and I think it had a tag on it that said it was for a projector, like what they use at the movie house for rewiring the, I assume the lamps would be the hot part of it. So that should work well for going in here near where the heat is. Oh, and I also found 3 fans. The little, like the bigger computer fans. I think they're 12 volt, 0.4 amp. And I found a switching power supply, one of the plug-in wall warts that'll run from 100 volts to 240 and supply 12 volts for those fans. Because I want to be able to use it on 222 also, I should say. So I needed something that would go in that wide voltage range, and the fans aren't that way, so that power supply should solve that problem. So I'll keep plugging away, show you when I make some more progress. Here's one of the lugs after it's soldered in place. Makes it really nice and sturdy. It's still warm. Well, I got a couple more hours invested in the project. Thought I'd show you what I've got done so far and my ideas. Well, I went up in my other building to get a piece of sheet metal to build a base, and I run into this old range vent hood, and I thought, jeepers, that looks like that might not be a bad choice for a base. So I brought her down and got the holes cut out, got the circuit breakers mounted, and I got ideas. This is going to set on the top here, and then the wire cage will go over that, of course. And my 3 fans will go there, except they'll be on the underside. And I can use the fan switch here to turn the fan on and off. So I think I'll show you the other side. There's the underside with the breakers mounted. Now the only problem I'm having with this is that the breakers stick down below the height of this, so I'm going to have to extend this a little bit, and I haven't quite decided exactly how I'm going to do it. I wanted to try to make it look halfway decent, but maybe I'll just wind up making a piece and wrapping around and doing the pop rivet deal. There is a lip here, but it's pretty thin, and it's going to be kind of hard to work with, but I might make a little sample piece and give it a try, because that would make a lot nicer looking seam rather than having that overlapped in the pop rivets. So that's so far I got so far. Got the extension made for the range hood. I folded up a test piece and figured if I made it about 4 inches, I'd have room to work my rivet gun, and I wouldn't be real confined with my wiring either. It'll make it a lot easier. So I couldn't make it all in one piece. I had to make 4 pieces because my brake is only 30 inches. Box and pan brake's only 30 inches. So I made the front piece, the 2 side pieces, and the back piece, and they're riveted on. This is only 3/8 of an inch wide, so, and I got a bottom made over there for it, and I also got the holes punched for the line 1 amps and volts, line 2 amps and volts, cycle meter, hertz meter, and the switch for the series parallel. And on the top side I got the 3 holes for the fan, the mounting holes, and I got 8 holes here which will hold the grommets for the wires to go down through. And this is the original exhaust exit. That'll now be the input where the air goes in. I'll probably put a piece of screen over that too. But I think my next move is going to be get her cleaned up and throw a coat of paint on her, then we can start assembling it. Now I threw some paint on it, got some labels on it. The only reason I painted it red is because I had 2 cans of red. Worst paint I ever used. Rust-Oleum Painter's Touch. General purpose paint. Good for wood, wicker, metal, and more. Well, I don't know. I don't think it's good for anything. I'd never buy it again. Didn't even cover up my pencil lines where I put my labels on. Oh well, that's enough for the ranting about the paint. What I do is I put vinyl letters on. The original paint's underneath. I paint it, then I pull it off. That way you've got some permanent labels. I'll show you one here. Just like that. So I got all these to pull off yet, so I'm going to work on that. Yeah, I got the stickers all off for the labels. Got her assembled. And I left the cover off just so I could show you some of the wiring. This is that high temperature wire. And that's where I got the input. And I think I'm going to put a piece of rubber inner tube or something over here that'll drop down over it just for a little extra protection. But we'll put you on the tripod and I'll just plug it in regular house current, give you a quick tour, and then we'll play with some generators. Okay, I'm just going to plug it in an extension cord with I just got a little clip cord on there. None of this wire is actually heavy duty enough. But here in the garage I got 122 volts. And I got this switch in series. And in order to use it in series, I got to have a switch on in each one. So I'll turn one on in the end. And the first one will give me 3.7 amps. And we'll go with the 2 lowest ones. 2.1, so that's as low as I can go. And each one of these just shortens up the length. So there's 2.2, 2.4, 6, 2.8, 3, 3.8, 4.2, 4.9, 5.4, 6, 8, 11, and there's about 16 and a half. Probably should turn the fan. So if I 2 amps. And if I kick one in over here, it should be twice that much. Yep. Okay, I'm back. I heard the camera beep. The battery died. I wish it would beep before the battery died, but that isn't how it works. So, let's see, I was going along with a parallel. I think I don't know. I'll start over again. Turn the fan on. Two breakers. Third, fourth, fifth, sixth, seventh. If I do the 8th one, it goes to 30 amps. I don't want to burn my cords up, so I won't do that. Then if I go over here, I can add to it 24 or 21, 22, 23, 26, and there's about 30 amps. And if I turn both these end ones on, it'll draw about 60 amps on 120. But that's only one of the coils, and they light up pretty bright red, so I think if I want to put a 30 amp load on, I'll do it like this. I better shut it down or my cord's going to go up in smoke. That gives you an idea how it's gonna work. So let's hook a generator up to it and see how it acts. Okay, I got the old new to me Onan just outside the door running. It's run for a couple minutes to warm it up. I'm going to shut the door. Okay, with no load, it's showing 126 volts. And we'll turn 2 amps. Still about 127. 2.4. 2.6. 124 volts, 60 cycles is holding good. 2.9, 3.2, 3.6, 3.9, 4.5, still 124 volts, 60 cycles, 5 amps, 124, 5.9, 123, 4, switching back and forth, 123 volts, 7 amps, 122, 8.9, there's 11.7 amps, 121, there's 17 amps, 119, 120, toggling back and forth. So, set these all down. That's as far as I can go in series. Put it on parallel. There's 4.4, 5.1, 6, 7, 8.9, 11, there's 14, 17. So we'll go over here and I'll throw some more on. 118 volts, 21 amps. 118 volts, 22 amps. 118 volts. volts, 22.7, 118, 23.9, 118, 25.6, still right at 60 cycles. There's 115 volts at 28 amps. My cords ought to start warming up pretty good now. The Onan seems to do pretty well. Now, if I turn all these back off, if I turn this one here on, it's going to put, I'll turn this one on over here. It should make it, there's 46, and it's still 104 volts, but the frequency dropped down. There's 32, 114 volts. So that's with the Onan, which didn't do too bad, I didn't think. Now I got the Champion. It's 4,000 watts also. Even with the door shut, it's noisy. Now I noticed with this one, when there's no load on it, the frequency is way out of whack, and I think it's because the power isn't very clean. Let's see, let's put it in series. Okay, as soon as I put a load on it, straighten this up. 2.2 amps, 124 volts. Work our way across, increasing it. Holds at 124 and 60. Up to 3 amps. There's 4.1, 124. Frequency's changing a little bit. 5.3. Frequency went to 57. 6.3. 123 volts. 7.7 amps. 123. Staying at 57 hertz. 121 at 9.7 amps. 119 at 13.2. 116 at 20.3. Dropped another hertz. So, okay, let's switch to parallel. Okay, there's 117 at 20 amps. 114 at 25 amps, 56 hertz. 26 amps, 114, 56. 27, 28 amps, 113, we're down to 55 hertz. 112 volts, 29.7 amps, still at 55 hertz. Uh-oh, she don't like that, it's gonna die. So don't like 30 amps. do as bad as I thought it would. Okay, now I got one of them little Harbor Freight tailgaters. We're going to give that a whirl. Okay, here's the next test subject. One of these little two-stroke Harbor Freight jobs. I think I got about 6 of them. I only paid hardly anything for any of them, but they all work great. If you can stand the sound of them. Okay, I want the series. Okay, we started out no load at what? 119, 60 cycles. 2 amps. 116, 17. Work our way up through 2.5 amps, 114, still at 60. 2.7 amps, 116. Of course, I didn't give it very much time to warm up. So there's 3 amps, around 116. 115, 3.3, 115 at 3.6, hanging right in there at 60 cycles. 4.1, 115, 4.8, 115, 5.5, 113 average, I guess. 6 amps, 6.7 amps, 113, still at 60 cycles. The governors work good in them. There's 8.3 amps, down to 110. That's pretty well loaded up for one of them. That'd be over 800 watts actually. Probably that's more like a full load for one right there. I didn't check the gas in it. I bet you it just ran out of gas. Well, at least it's quiet now. So that's my load bank. It does pretty much what I wanted. One thing I wasn't able to do with, I thought I could get each one of these to read individual banks, and especially when it goes on the 220, so you could see if one leg was higher than the other, or you could simulate. But for some reason it doesn't work that way. I don't know whether I have something wrong or whether it just isn't going to do that the way I have it plumbed. But that's my load bank for not much money and a few days worth of work. Like I say, I bought this in 2004 and I don't remember how much I paid for it, but it wasn't much or I wouldn't have bought it. And these meters are only like less than $5 a piece for these. They go to 100 amps, volt amp meters. These Hertz ones I think are only like $3 or something. So, and they seem fairly accurate. I used I compared it with this amp probe, and it was pretty darn close. This one over here reads just a tad higher, and I think maybe that's because I got my fans and the power feeding the meters through that one. So I guess if you enjoyed it, give me a thumbs up and please subscribe, and we'll see you next time.